In this video, we're going to go over section 4.3 from your textbook, which is all about standard deviation of a data set. So a standard deviation is a type of measure of dispersion. So in addition to finding the averages of a data set, remember we just talked about what the averages were. Averages are the mean, the median, and the mode. Those are all forms of averages. So in addition to finding the averages of a data set, we should also take into account the consistency or the spread of the data. So that tells you how spread out the data are. So for example, if you're looking at ages, are the ages all close together or are they really spread apart? So we can take into account the spread of the data by using measures of dispersion, which show how different the data points are from the average. Okay, so there are different measures of dispersion. The ones that we'll be talking about today are the variance and the standard deviation. We really are going to focus on the standard deviation, but we're going to find out in just a second that in order for us to find the standard deviation, we have to find something called the variance first. It's sometimes desirable to measure the relative consistency of a set of data. So let's say that you do an experiment. You want to figure out, are the numbers consistently bunched up or are they erratically spread out? The difference between a single data point and the mean is called the deviation from the mean, or simply the deviation. And it's given by x minus the mean, so x minus x bar. So here's what I want you to write down. I want you to write down that the deviation is equal to x minus x bar. You can put the parentheses around it if you want to. You don't have to, but if it looks better to you with the parentheses around it, you can go ahead and put the parentheses around it. Right, so make sure you write this part down because we are going to see this again in the next couple of slides. All right, standard deviation and variance. This section is all about standard deviation. That's our end goal, is to find the standard deviation. But in order for us to calculate the standard deviation, we have to calculate something called the variance first, because the standard deviation is based off of the variance. Here's the formula for variance. It looks kind of complicated, but I'm going to show you how we can use a little table to help us calculate the variance, and it will make it a little bit easier to plug everything in. This is the part that I want you to write down. I'm going to go through the definition really quickly, so if you want to write it down first, you can pause the video. If you're given a sample of n data points, so again, n is the number of data points in your data set. So given a sample of n data points, the variance of the data, denoted by s squared, is s squared is equal to the sum of x minus x bar squared divided by n minus 1. Alright, so again, that numerator where you see that sigma, that Greek letter sigma right here, remember we talked about in the last section that that's sum notation, S-U-M, sum. So that's sum notation. So when you see that, you know that that's telling you to add up all that stuff. So it's the sum of the deviations squared divided by n minus 1. Okay. So and then at the bottom it says the variance of a sample is found by dividing the sum of the squares of the deviations by n minus 1. The symbol s squared is a reminder that the deviations have been squared. Now let's get to the standard deviation, which is our, like I said, our end goal. Here's the formula for the standard deviation. This is the part that I would like you to write down. It says, given a sample of n data points, the standard deviation of the data, denoted by s, is equal to, so it's s is equal to the square root of the variance. Right, so s is equal to the square root of the variance. And then at the bottom, this is also important. You may also want to write this down. It says to find the standard deviation of a set of data, first find the variance, and then take the square root of the variance. Alright, so to find the standard deviation, you find the variance, and then take the square root of the variance, and that'll give you the standard deviation. Let's look at an example. This example looks really similar to the problem from your homework. So I'm going to go through this example, and then I'll go through part of your homework. It says, George bowled 6 games, and his scores were 185, 135, 200, 185, 250, and 155. Find the standard deviation of his scores. Right, now, this is the table that I was telling you that we're going to use. I will give you this table on the test, or on the quiz. I'll have a picture of this table in there for you, and you can just copy it down onto your paper. Now let's look at what this table is made up of. And we'll also think about the formula as we go through this. I'm going to go ahead and pull up the formula for the variance and the standard deviation. Okay, so the first column is just for your data values. So this is where we're going to put these numbers right here. Your book likes to put them in order from smallest to biggest. It doesn't matter. I'm going to put, in the first example that I'm going to do, I'm going to put them in order from smallest to biggest. And then in the next example, I'm not going to put them in order, and I'm going to show you that it doesn't matter how you do it. Alright, so in that first column, that's where your data values go. In your second column, that's where your deviation goes. Remember, this part of the formula right here, this is the deviation. So it's just x minus x bar. Alright, so x minus the mean. So that column is for the deviation. And then the next column is for the deviation squared. So you're going to take whatever you find in the second column and you're just going to square it. I'm sure you all know, but when you square something, you're just multiplying it by itself. Alright, so that's where this part comes in, the squared part. We take care of that in the third column. Now at the very bottom down here, you'll see the sum. Sorry, my circle was kind of off there. You'll see the sum. Now, we have that there because of this piece of the formula, the sum. Alright, so that's going to take care of that sum part. So this table is only going to tell us this piece of the formula. It's only going to tell us the numerator of this formula. Alright, and then after we find out what the numerator is equal to, we'll have to go off to the side, divide by n minus 1. Let me just remind you that n is the number of data values that you have in your data set. So let's see what our n value would be here. This is 1, 2, 3, 4, 5, 6. So our n value here is going to be 6 because we have 6 data values. Sorry, my 135 already popped up there. Now, let's talk about what we'll do after we figure out what n minus 1 is. Alright, so after we figure out what n is our the number of data values that we have in our data set. It's also called the sample size. Alright, so after you figure out what n is, we've just figured out here that n was 6. You're going to take and do n minus 1, so 6 minus 1 would be 5. Then you're going to take whatever number you find down here, divide it by 5, and that's going to tell you the variance. Now the variance is always going to be a pretty big number, so if you get a really big number, don't be alarmed. That's normal. And then after we find the variance, we're going to move on to the standard deviation formula, which is down here. Alright, so we'll move on to the standard deviation formula. And all you have to do at that point is you just take the square root of whatever you found the variance to be. Now make sure you locate the square root button on your calculator before we get started. So you might want to pause the video, figure out where your square root button is. That way when we get to that part of the problem, you won't be scrambling trying to find it. Alright, let's start filling out the table. I've already got the first data value filled in. Like I said before, I'm going to put these in order from smallest to biggest. You do not have to do that. I'm just doing this, I'm just following along with your textbook, and this is the way they do it. But like I said, in the next example, I'm not going to put them in order, and then you'll see that it really has no effect. Alright, so filling out the data value, or filling in the data column, 135, 155, 185, then 185 again. It's important that you include both of those. Then 200 and 250. Okay. And then our next column, deviation. So there's the deviation. Remember, we just wrote that definition down. It's x minus x bar. I have the parentheses around it here. Like I said before, you don't necessarily have to have the parentheses. We are going to talk more about the parentheses when we get to the deviation squared column. Alright, so you can see that in order for us to find the deviation, we need to find the mean. Alright, so we're just going to go over here to the side and we're going to find the mean. Okay, so to find the mean, I'm just going to take the six scores and I'm going to add them up and I'm going to divide by 6. So 185 plus 135 plus 200 plus 185 again plus 250 plus 155 divided by 6. Okay, so all of that, the numerator there, if you add that all together, that adds to 1,110. So 1,110 divided by 6 is 185. Alright, so our x bar is going to be 185. So for our first deviation, very important that you go in this order. So it's the data value minus the mean. Alright, so data value minus the mean. Alright, so 135 minus 185, that is negative 50. Alright, then our next row, 155. Alright, let's look at our next deviation. So our next deviation is going to be 155 minus 185. So 155 minus 185, again, that's data value minus the mean. So 155 minus 185 is negative 30. Alright, then our next deviation, our next row is 185. So that's going to be the data value minus the mean is 185 minus 185. Alright, so 185 minus 185 is 0. When this happens, this is always nice because it gives you less work to do when you end up with 0. Alright, once again we have 185, so data value minus the mean is 185 minus 185. Again, the mean is also 185, so that's just the way it worked out. Okay, 185 minus 185 is also 0. Alright, then we have our next data value is 200. So 200 minus 185, again, that's data value minus the mean. This is going to give us a positive 15. Alright, and then our last data value is 250. So data value minus the mean is 250 minus 185, which is 65. Alright, now we've finished our deviation column, which means that right now we have figured out each one of these little deviations right here in this formula. So we've done this part of the formula, which that's the worst looking part, so maybe that'll make you feel better that we've got that part done. Now we are going to square the deviations. Now I want you to listen to me very carefully when I tell you what we're about to do. This column is very simple. All you're going to do is just take the number that you found in that deviation column. Alright, so take the number you found here and you're going to square it. So you're going to multiply it by itself, or you can just use the squared button on your calculator. Alright, if you don't see a little squared button, you may see a button that looks like this. So I'm drawing on the right upper corner up here, so it looks like a caret. That is the button that lets you raise things to a power. So you would press that button and then type in 2 to raise it to the second power. But most of you probably have a squared button on your calculator. All right, but the important part, and what I want you to listen carefully to, is the following. When you are squaring a negative number, it needs to go inside parentheses when you type it in your calculator. Okay, so let me repeat that. If you are squaring a negative number, you must put it inside parentheses when you type this in your calculator. So it should look like this, parentheses negative 50 squared. And also something else that I've seen some people get an error with before, make sure you use the negative button and not the minus. If you use the minus button, it'll give you an error. Alright, so negative 50 squared. Again, I've got it inside the parentheses because it's a negative number. If it's 0 or if it's positive, you don't have to put the parentheses, but you can. It's not going to mess it up. Alright, but negative 50 squared is 2,500. If you don't put it inside the parentheses, this will give you negative 2,500, which is incorrect. Alright, let's square our next deviation. This one is also negative, so we're going to put negative 30 inside the parentheses, so negative 30 squared. Negative 30 squared is 900. Alright, then we're moving on to our easy deviation, which was 0. 0 squared, that's just 0 times 0, which is 0. Then once again, we got 0 again, so 0 squared, 0 times 0, which is 0. Alright, then our next deviation, this is a positive number. So just like how we did with 0, you don't have to put this inside parentheses, but like I said before, you can put it like, parentheses 15 and then square it outside the parentheses. So that's totally fine if you do it that way. 15 squared is 225. And then our last one, 65 squared. 65 squared, I missed that number. Let me tell you what that is. I don't know it off the top of my head. 65 squared is 4225. Maybe it'll pop up in a second. 4225. All right. So now we are going to take that sum that we just found. You're going to add up all of your deviations. Let me write in the 4, 2, 2, 5. That way there'll be no confusion. After you find all of your deviation squareds, then you're going to add them all up, and we add them. Remember, we're adding them all up because of this piece of the formula over here, that sum. So you're adding them all up. When you add them all up, they add to 7850. So then you're going to take that and you're going to go over here and plug it into your formula. Alright, so that goes in for the numerator. That's the entire numerator that sum is. So we have 7850 divided by n minus 1. We said that n is the number of data values that are in our data set, which we said was 6, because there are 6 data values. So we need to plug in a 6 here for n. So that's going to be, oh, there, look, see, my 4225 just popped up. Let me erase that so it looks a little cleaner. Alright, so we're plugging in the 6. So 7850 divided by 6 minus 1. Now we need to go ahead and simplify the denominator first. So 6 minus 1 is 5. Now we can do that division. So 7850 divided by 5 gives you 1570. Alright, so that's your variance. So now, like we said before, you need to take that variance and you're going to plug it in to your standard deviation formula. So the standard deviation is S. That's going to be equal to the square root of 1570. Right, and the square root of 1570 is 39.6. So there is your standard deviation. That's your answer. 39.6 is the standard deviation. So that gives you an idea of how spread out the data points are. So it says, like, this is sort of tells you on average how far apart or how far away from the mean your average data value is. All right. Here we go with another homework problem, or with a homework problem. So this is section 4.3 homework problem number 1. This is actually the only homework problem that's on your assignment for this section, so there's only one problem on the homework. And I just put one problem because these problems are pretty long. So I didn't want you to have to spend a whole bunch of time working on this homework assignment. So you can see this problem, it says Joey and Dee Dee bowled 5 games at the Rock and Bowl lanes. Their scores are given in the following table. Right, so as always, remember that the numbers that are in red, those will be different on your assignment. So I'm just showing you how to do it. You'll have to plug in your numbers to get your answer. Part A wants you to find the mean score of each bowler. Super simple, you're just going to add up their scores. So for example, we'll add up Joey's scores and then divide by 5. That'll tell you Joey's mean score. Then the next part, you'll have to tell who has the highest mean, so super easy. And then they ask you to find the standard deviation of each bowler. And it says to round to 1 decimal place. And then the last part asks you who is the more consistent bowler. So we'll talk about what that means after we find the standard deviation. I'm just going to do Joey's part of the problem. And then I'll let you figure out Dee Dee's part, which it's exactly the same. I'm going to pull back up my table and I'm going to start filling in my data values. So first, let me pull up the formulas. There's variance and there's standard deviation. Now we can start filling in the data values. I'm not going to put them in order this time from smallest to biggest just because it doesn't matter. You can do it however you want to do it. If you like them being in order, then that's great. You can put them in order. Alright, so this time I only have 5 data values, so this is going to leave me with a blank row because I just used the same table from the last problem, but that's okay. It's not going to mess anything up. Alright, now I need to find my deviations. And remember what we just talked about, when you find the deviation, you need to know the mean. Alright, so I'm going to go over here to the side, I'm going to find the mean. And that's actually going to go ahead and take care of part A for you. So again, I'm doing Joey's scores, so I have 140 plus 166 plus 217 plus 154 plus 163 divided by 5 this time because there's only 5 data values. So if you add all those up, that gives you 840 divided by 5, which is 168. So that's Joey's average or mean score. Now I can plug in 168 for my deviation, or plug that into my little deviation formula in my table. My first deviation is going to be 140 minus 168. 140 minus 168, so that's, again, the data value minus the mean, and very important that you do it in that order. Data value minus the mean, which is negative 28. I have like an extra minus sign in there. Let me just get rid of that. If I can. Well, that didn't help at all. Okay, there, I kind of got rid of it. Alright, so it's just negative 28. Y'all, I'm struggling in this video, but we're going to get it done. Alright, the next deviation, remember it's the data value minus the mean, so 166 minus 168, which is negative 2. Then our next deviation, 217 minus 168, data value minus the mean. 217 minus 168 is 49. Then our next deviation, 154 minus 168, this is also going to be a negative number, you can already tell. That's going to be negative 14. And then our last deviation, 163 minus 168, is negative 5. Now, what do we do next? Right, next, we're going to square those deviations, and we're going to remember to be very careful to make sure and put parentheses around our negative numbers if we're squaring them in the calculator. Right, so negative 28. Negative 28 squared, again I have it inside the parentheses, is 784. Negative 2 squared, that's just negative 2 times negative 2, is 4. 49 squared, see I don't have the parentheses around this one because it's not negative, it's positive. 49 squared is 2401. Negative 14 squared, got that inside the parentheses, is 196. And then -5 squared is 25. So I went ahead and added those up. That gives me 3,410 when you add up all those deviation squareds. All those squared deviations is probably a better way to say it. All right, so now try to remember where that goes in at. All right, remember this sum replaces the entire numerator over here. All right, so that replaces the entire numerator over here. So let's do that next. Go ahead and plug that into your formula. So 3410 divided by n minus 1. What's our n value here? How many data points do we have? 5. There are 5 data values in this data set. So we're going to replace n with 5. All right, so 5 minus 1 is 4. Got to do that first. All right, so 3,410 divided by 4 is 852.5. So there's your variance. Now that we've found the variance, now we can find the standard deviation. That was our whole entire goal, was to find the standard deviation. All right, so we're just plugging in 852.5 for the variance. All right, so this is going to give us the standard deviation. So the square root of the variance, or the square root of 852.5, is approximately 29.2. So I think it's 29.19 something. So since they told us to round to 1 decimal place, that gives us 29.2. So there is your standard deviation. All right, and then the last thing I want to talk about just really quickly, because I know this video is getting kind of long, is that last part right there, who is the more consistent bowler. All right, so when we're talking about standard deviation, you're going to get a more consistent bowler or a more consistent data set for the data sets that have lower standard deviations. Okay, so again, the bowler who is more consistent will have a lower or smaller standard deviation. So you just pick whoever in your problem, whoever ends up with the smaller standard deviation, whoever ends up with the smaller standard deviation, that is going to be the more consistent bowler.